And the next reporter is our well-known omnipresent Yuri Raizman. If there is no Yuri at a conference, this is a false conference, fake conference, because he's a real driver for new technologies.
Thank you for this warm and comprehensive introduction of me. Those of you who don't know me, let me still make my own introduction. I am from VisionMap, based in Israel, and we design aerial photography equipment, digital aerial cameras, and program and software for photogrammetric applications. Today we will talk a little bit about new developments. This year has been full of various events for VisionMap in terms of development as well. Now, what did we do this year? First of all, we launched a new line of cameras, A3 Edge, that surpasses the existing A3 line of cameras across the board by all parameters. It has been marketed and is users are starting to apply it more and more active. It includes A3 Core. This is a camera without oblique images, because a regular camera provides for both. A3 Core does not have oblique capability, and A3 Edge provides you with infrared band capability. We also produced and issued 2 new versions of light speed processing, improved greatly the functionality of it, especially when automatic radiometry processing is involved. You know, this is a fully automatic system, as Viktor Nikolaevich showed you. You press just one button and you generate an ortho photo. I'm going to walk you through it later. Flight viewer software. It's important during the flight or after the flight to know whether it was a good quality flight, whether you had any cloud cover, are there any holes in the coverage. This is a new program issued recently. I'll run a video for you. Oblivision, an Israeli-based company, Iden Computers, has provided us with software to view orthophoto and oblique images, and for measuring of metric measurements on oblique images. It operates in both network mode and standalone mode. 3D city modeling is a very popular subject these days. We implemented Acute 3D engine. It's a company located in the south of France. At the moment, this is an engine used by Astrium, Pixel Factory, the key players. We use that as well. So I'm going to run an interesting video for you. That's aerial survey of Jerusalem that will provide you with a quality tour of this model. So you can create a very good, well-textured city model using it. One of the major activities this year was joint work with Rakurus. We continued to deepen cooperation, improved understanding. We improved stereo mode, stereo compilation feature. We're finishing this month, but plans abound for the future. And cluster server configuration. You know that we provide a turnkey system. It's not just a camera. It goes with equipment and software specially configured for our system. This year we started to use server options. We began with cluster options many years ago, but cluster options are okay. You can process tons of data, but not everyone needs tons of data. Some companies have little information every year, and for them server applications are just all right. In fact, server options can be equated or be identical with cluster options. This is how our camera looks. This is the system cluster, A3 core, A3 edge. Outwardly they look the same, some of the parameters. It weighs 38 kilograms, size 50 by 60 by 60, focal length 300 millimeters. That allows to fly high and see wide and far. You can have very good ground sampling distance. It delivers in RGB or RGB plus CIB. This is where the difference comes on 72, 110 degrees. Other parameters are more or less identical. This is aerial survey productivity data for A3 core and A3 edge. We are talking thousands of square kilometers every hour of aerial survey. If you need to have 10 centimeter orthophoto and you obtain 8 centimeter accurate resolution, then every hour you will be able to generate 1,000 square kilometers every hour. If you're after 20, then you will get 7,000 square kilometers every hour. So it's task specific, and at any rate the productivity is very high. This a comparison curve between the company camera leaving the market and the replacement camera. The new one will have better productivity, better resolution, and higher resolution. If you have altitudinal data, elevation data, it utilizes a shutter-free matrix. This is the new matrix produced by Kodak. So they go without shutters and they provide much better quality. This is a top-of-flight program, software designed just for us. It takes into account relief features, and you can see the difference between A3 edge and an average digital camera, like large format digital cameras. You can see the difference here very clearly. A few examples of survey carried out by A3 edge. Height 2,000 meters, ground sampling distance 5 centimeters. This is the God's Coffin Church. I'm now going to make a pixel to pixel amplification. So this is the front yard in front of the church. You can see all the tourists walking around, and you can see how they are dressed. You can count all the stones and edges on the dome. These are parts of Jerusalem. This is David's grotto. These are towers of David. Those of you who walked up the walls of Jerusalem here might remember this steps skirting the walls of Jerusalem. A few images from Jerusalem. You can see a swimming pool. This person must be a little boy using an inflatable cushion we can count the number of people sunbathing in this penthouse. The higher you fly and the better GSD you have, the better productivity you will have. No secret there. You can monitor construction projects with good ground sampling distance. You can use ObliVision as an intermediary software that provides you with an opportunity to look at it at the site from various sides and see how much has been completed in 1 month. This image was taken from the altitude of 6,700 meters with a GSD of 16.5 centimeters, but still there is a lot of stuff we can see. We can see the numbers of parking slots. So this is nearly 7,000 kilometers. This is not the latest image made. This was an interim prototype using another CCD, but still the new camera provides even better quality. Let me now share with you a few videos that will help you get the feel of how it works, what speeds are involved. This is a flight viewer software that can run on any laptop, on flight or after the flight. The imaging data can be read out immediately from the computer and the camera or be downloaded on this laptop. This is how it processes it or views it. You can change strips, alternate strips, verify data between the strips, check all the data. You can mark areas of interest or areas of concern and upload them as shape files or export them as shape files. You know that we use bookmarks, special marks that allow you throughout the whole session to view certain things of interest. You can see a histogram of images. You can mark any place. You can go to Google or Yandex and see what they have to offer for the same area. See where the project was done. ObliVision, unfortunately, this is an online system which is available in the internet that allows you to quickly represent ortho photos and all oblique images when you point show a certain point in ortho photo that gives you all the images it has, and you can carry out measurements in mono mode, not stereo mode. Unfortunately, the connectivity here is not very good, so we couldn't launch it even though we tried. This is one of the latest achievements. Not sure about... Well, again, this is Jerusalem. The survey was done specifically for oblique applications, 6 centimeter GSD. And we then took our images, exported them, triangulated them, exported them in Acute 3D, and using Acute 3D software we generated this model. This is a bird's view. Now we're going to zoom in on it to reveal some of the interesting places. This is the western wall. We represented this model in Stuttgart a week ago. This is the Church of Dormition. It does produce a very good impressive, a very good impression. Even in the very shady, narrow alleys, we managed to create very good models by combining different images that we had. This is Church of the Holy Sepulchre. In fact, these models do exist these days, and we can create them not for one house or one church, but for the whole cities. And that takes what? It doesn't take a lot of time. Well, my time's up. I understand. Thank you very much. You made it just right. I didn't. It was so exciting. We could continue listening to.
Вы, вот давайте вставайте. Да, я вам слово дал.
Yeah. Mr. Adrev Rakurs, about 3D models that you showed. Did you use one camera or two cameras placed at 45 degree? This was done by one camera with overlapping strips. So you had overlapping strips, right? Yeah. You have very wide angles resultant. Then what about survey parameters? Did you increase the angle? Was it the height was the height was about 2 kilometers, 2200 meters. The speed was 220 kilometers per hour. At that speed, A3H cameras allow to open field of view up to 100 degrees. Up to 100 degrees. So the field of view. So it was 50 degrees off the nadir. I hope you're happy with the answer you got. Can you tell me, please, if I understand you correctly, in your camera there are lenses and other details that move, and so what's the life? How long do they last? And can you use it in space? Okay, it is possible to use it in space. We received similar offers. We are working on it. It is possible. About how long they last, we don't use mechanical parts. The only revolving part is electromagnetic engine, but it has no mechanical parts. So it's all about electronics, how long they endure. No mechanical parts whatsoever. You said that field of view increases and the swath width changes also. What about distortions along the edges when you open the field of view? How does it do on the edges? Okay, we're looking at 5-6 kilometers survey. Yes, if you take 100 degrees, so it's a tangent of 50 degrees, 50-degree angle. It's not a distortion per se, I would disagree. It's an oblique image. This will be an oblique image. Yeah, nadir is nadir. Okay, let me put it this way. If you use it for orthophoto applications, the edges are not used for orthophoto. They are cut off automatically. I was wondering about the swath. How much do you able to cover? Well, we stem from the following postulate. From 2-kilometer height. Is it or from 1 kilometer? That's a tough one. It's difficult to say. I think we need to discuss it from a different perspective. What perspective? Well, let me tell you this. There is an effective field of view, right? We have the field of view and the effective one that is used to create orthophoto. This effective field of view or orthophoto angle depends on the required accuracy that you want to have for the final product. If you want to make 10,000 or 5,000 scale orthophoto, so it can be 50 or 60 degrees, which is perfectly fine to conform local standards, which is what we did previously for different strips. So if we take an analog camera, RC30, and 20 to 30 overlap, so this is just enough to create orthophoto. All the rest is used for triangulation. Thank you, Yuri. You are a tough cookie because people want to ask you questions all the time. Well, you all remember how Rakus started. They went to Irkutsk, installed a free software. Well, that's correct. Unfortunately, I wasn't able to show everything that I wanted to show.